Today, you will understand, I will explain you what is shape of the distribution is all about. Okay, as part of this, we'll delve into the concept of distribution, pattern of your variable or so. And also we'll explore its various shapes, various type of shapes, and discuss the advantage of understanding them. Okay, let's get started. Okay, to begin, let's define what is the shape of a distribution is all about. Okay, which is nothing but it helps the overall pattern or form that a data set or a set of data points assumes when we plotted on a graph. Okay, so this is how it is. Something, let's say you have given an income data set. Someone given the income for your department employees. You have in your department you have 20, or let's you have 50 employees are there. Each employee's income you have it in your hand, and when you plotted it in a histogram or a box plot, or let's say histogram, when you plotted it, you can see something like this. In the histogram, when you plotted the 50 employees salary in your department, you can see the shape appears like this. The income is a variable, right? And the income variable appears to be a normal distribution. Appears to be no. So this is the pattern. We can see that for so in the x-axis I plotted income. In the y-axis it's nothing but the frequency. Okay, frequency. This is what your income. When you plotted the income for different employees, this is a normal distribution. Hence the mean will be there in the middle. Okay, this is right. So to understand, first you need to understand the pattern of your data set. Okay, in this case, this income variable or data points assumes the it assumes the, or when we plotted the income here, we can see that it is a normally distributed data. Okay, and so what is shape of distribution in simple term? What we are going to understand with the help of the this shape of distribution, by understanding this, and what you are going to, how it is going to be helpful for you. This is the right question. By understanding the shape of the distribution, okay, it helps you to understand how the data is spread out over the range of possible values. Look here, when I plotted the income in my histogram, I can see that this is the spread of my data set. Okay, how spread out my data set. So understanding the distribution, this distribution, this is your normal distribution. The shape of distribution in this case is a normal distribution. This is a normal distribution. It is also called a symmetric distribution. Symmetric, or some people they call it a Gaussian distribution. But if you talk to HR guy in a company, they will use the term bell curve. They call it a bell curve. Okay, they use different terms. Try to be used to these terms, because when you talk to the customers in USA, once you get into project, they use different terms. Some guys say symmetric distribution. So hey, can you see Gaussian distribution after you plotted the data? Yes. So which means he's talking about bell curve or normal distribution. Okay, fine. So what other advantages are there to understand the shape of the distribution? One advantage is we can understand the spread of the data set. Okay, how far the data are from the mean. Okay, whether is this something like too wide, the distribution, or the distribution or the spread is less wider, or too wider. Too wider is tells us quickly, hey, you have a lot of inconsistent values are there in your data set. Lot of volatility is there. And apart from this, the shape of distribution can help you to find out the outliers in your data set. So what do you mean by outliers? We know very well, right? The data points which are significantly different from the rest of the data, or some values are extremely very high value. Some values are, extremely very small value compared to the majority of the data in a data set. So using by plotting the data in a chart, we will importantly in histogram, you can find out the shape of the distribution of that given specific variable or data point. How spread out the given values in your data set. Take for example, the case of income. Is this too wide, the spread, or is this not too wide? The second advantage of finding out the distribution pattern of your data is it helps you to find out the outliers in your data set. And apart from this, it will help you to compare different populations. Okay, for example, you want to compare the distribution of heights of men and women. In your given data set, you have the heights of our men and women. If you want to compare the two different populations, in that kind of situation, also shape of distribution is very much helpful. Is shape of distribution, the shape of distribution is nothing but the overall pattern of the given data points. Okay, overall pattern of the given data points. For example, I have an income variable. I have plotted the income variable in a histogram. So using histogram, we can find out the distribution pattern of given data set. First of all, they'll ask you, tell me what is shape of the distribution. Okay, fine. Okay, overall pattern of the given data set. Once you plot the data in a chart, it gives you the distribution pattern. With that, you need to understand whether, so this is one distribution pattern, this is another distribution pattern. This pattern tells us quickly, hey, the spread is too wide. In this case, the spread is not too wide. Okay, good. Okay, how do you find out whether the given data set or given data points are normally distributed or skewed data? How do you find out how will you find out the pattern of the given data point? Histogram. I use histogram to find out the distribution pattern of any given data. Okay, fine. And what are the advantages? Next step is, what are the advantages? Okay, fine. Using histogram, you can find out the distribution patterns. Okay, finding the distribution, whether normal distribution or skewed distribution, how it is going to help? It helped me to find out the outliers in my data set. And also it helped me to compare different populations, like the distribution of heights of our men and women. If you want to compare in that kind of situation, also it is very much helpful. And again, there are some statistical tests that makes an assumption of normal distribution of the data. If your data is not normally distributed, then you cannot conduct this statistical test. Okay, fine. Next, right, this is what I explained you. Okay, and understanding the shape of distribution helps in selecting the appropriate model also. In the case of machine learning model, the distribution pattern helps you to choose the appropriate model. Okay, there are different types of shape of the distribution, the normal distribution, the one which I discussed so far, and skewed distribution, the left skewed distribution, right skewed distribution. And apart from this, we have uniform distribution and bimodal distribution is there. What is skewed distribution? The skewed distribution, it will have a longer tail on either on the left side of your data set or the right side of your data set. Okay. And uniform distribution is, it's a flat shape. And bimodal is, you will have two peaks in your data set. You have two peaks. In this case, you will have two peaks. Don't worry, I'll explain everything. In this case, you have two peaks. Uniform distribution is, it's a flat shape. For example, in the case of skewed, the left skewed data. In that case, what will happen is your shape will be something like this. It will come like this, and then it will get skewed like this. It is not a normal distribution. It's a left side of the peak, right? So the left, this is your peak. The left side of the peak, if you find a longer tail, with that you can understand quickly, hey, this is a left skewed data. Left side, the value got skewed here. So what does it tells? What does it tells us? So it tells us there are more data points with lower values than with higher values. Okay, more data points with lower values than higher values. That is what it tells us. Okay, and the opposite is your right skewed data. Anyhow, we will explore with some data set so that you will be able to understand all these type of distribution very clearly. Okay. First of all, what is a normal distribution? What is the symmetric distribution? What are the properties of symmetric distribution? Symmetric distribution is also called a normal distribution, bell curve. It is a type of distribution where the left side of the distribution mirrors the right side. The left side mirrors the right side. Look here, the entire left side here, right? The left side thing, the same thing, it get mirrored on the right side also. This is one of the properties of symmetrical distribution. And in the case of symmetrical distribution, the mean, median, mode, all these three values are same. The mean, median, mode, all the things. See, in the middle, the mean will come here in the middle. In the case of normal distribution or symmetrical distribution, the mean will appear in the middle. In the case of normal distribution, remember that mean and median, mode, all the values are same. All the values are same. This is one of the common distribution. Okay, in this case, you will have a single peak in the middle. You will have a single peak. Look here, this is only one peak is there, right? This is called your peak in the middle. Only one peak will be there. And the data is evenly distributed on either side of the peak. Look here, here also the shape comes like this. Here also it comes like this. So the normal distribution is the most common example for the symmetric distribution. That's all. Very simple one, right? Now let us take some data set and then we will see whether it is a, so, okay. So can someone tell me is this a normally distributed data or not? So this is a given data set. Someone has given you the income data. Okay, your manager has given you the income data. Hey, I want you to find out whether are we giving the salary in a very fair manner without bias. Are we giving the salary to our population or our employees? So this is one of the common issues in USA, right? They can see some kind of the gender bias is there when it comes to salary. So compared to female, male, they get more salary. There should not be any gender bias. There should not be any bias with respect to salary. So to find out that, you need to plot the income data in a chart. With the help of the chart, you can quickly make out, are we really biased or unbiased? So now your manager has given you this data set. Okay, and 0 to 100. So how many is 0? So it tells me, this one tells me what? None of the individuals have income between 0 to $10,000. In this case, one individual has an income between $10,000 to $20,000. And here, if you see, 23 individuals have an income between 20,000 to 30,000, and 136 employees or individuals have an income between. This is the one, we can see that. When I plotted this data into in an histogram, so this is what my income, the x-axis I plotted the income, in the y-axis the frequency, right? The frequency comes for your y-axis. When you plotted this, it shows us very clearly the income data is approximately normally distributed. Need not to be exactly like your bell curve. In real world scenario, you cannot get it like this. It will not be exactly like this. Okay, it will be somewhat approximately normally distributed. This one seems to be approximately normally distributed with peak in the. So where you can see the peak here, peak. What is peak? I'm talking about peak. In this histogram, where you can see the peak here, right? This is the tallest one compared to others. So in this case, what it tells us the story very clearly. You don't have to see the data itself. Simply you can see the chart. As a data scientist, by looking at this, you can tell the data. So you can tell the story, right? The data tells us the story. In this case, we don't have to see the data at all. So what story it tells us? So we have a single peak in this case. Okay, and here the 40,000 in the peak, we can see that 40,000 and 50,000. So this is the most common income range. So here the 40,000 to 50,000, this is what the peak we can see it, right? That is what I said. Look here, 40,000 to 50,000, 364 employees are getting this salary. So with that, we can tell very clearly the most common income ranges between 40,000 to 50,000. 364 employees compared to others, right? Here only 335. 118 employees are getting the salary between this range, and none of the employees are getting the salary between this range. 23 employees are getting. So here, majority of the employees are, here, right? We can see that here 364. 364 employees are drawing the salary between this one. So here we can see that, we instead of saying this way, we can refine our statement and say the most common income ranges 40,000 to 50,000, because the peak is here. As soon as you see a peak here, you can see what value you have it here. You can, with that, you can tell very clearly this is the most common value in your data set. It is appearing multiple times, right? Many people are getting salary in this range. What are the least common income ranges? What are the least common income ranges? 0 to 10,000. 0 to 10,000. And what other values? See, this is the one, right? Least income. 8,000 to 9,000, 80,000 to 90,000, and 90,000 to one, this one. So in this range, we don't see any individuals are falling in these brackets, right? In this case, this is the least common income range. The income, what is the income distribution here? The distribution of the income variable is approximately normally distributed around 40,000 to 50,000 range. Most individuals in my department, they make a salary between 40,000 to here in this case 40,000 to, we can see 40,000 to 60,000 also, we can say, right? We can see that 40,000 to 60,000. So these two, if you see here, these two are tall, right? Compared to these two, this one is the peak. Okay, this is the most common income range is this one. And if but the other, even this one also, almost taller than almost as tall as this one, isn't it? There's a little difference here, but still we can tell the story like majority of the individuals make a salary between 40,000 to 60,000, with fewer people making less than 40,000. Okay, if you see, it is less, right? Only few people, they are getting lesser salary, and only few people are getting higher salary. Only few people are getting lesser salary, only few people are getting a higher salary, and majority of the employees, their salary ranges between 40,000 to 60,000. Very interesting story, isn't it? Yeah. So then how do we say it is a normal distribution? How we can say that, by looking at this data set, how we can say that we are not biased? Obviously, you think in a company, all the employees will get very high salary? All of you, please respond in the chat window. Say yes or no. Let's say you work for TCS. You think in TCS, 7 lakh employees are there. All the 7 lakh employees are getting every month 1 crore salary. Each and every employees, are they getting 1 crore? No, right? Please make it fast. It's a very simple common sense question. You think you will get 1 crore? Jai Shri? No, right? And Fatima and Shri, you are correct. Sarah, you are correct. Not all the employees. Jai Prashant, you are correct. How about Jivanandam? Jivanandam, your contribution is required. Jivanandam, Jiva, are you there? Right? Not all the employees are getting very high. Only few employees. How come the few employees are getting very high salary? Because they are the CEO, Chief Financial Officer, CFO, C-level executives, and VP, Vice President, directors. They are the one getting very high salary. But if you look at the number of directors, number of CEOs in a company, very few people will be there. Only few people are getting very high salary. Very high salary. Hence, the height is very less. With the height itself, we can find out only few people are getting very high salary. But again, on the extreme right side, we can see that very few. And extreme left side, if you see here, only few people are getting less salary. Only few people are getting very less salary. Only few people are getting very high salary. And rest of the common salary ranges between majority of the most common salary or 40,000 to 50,000. But majority of the people's salary ranges between 40,000 to 60,000. So now the question is here. So only few people are getting salary. Why less salary? Why only few people are getting less salary? In our company, not all the people are executives. There are some people, they are doing some cleaning work in your office, right? They do office cleaning, everything. Every day morning, they come clean it, and evening they clean it. And there are some, in the case of software industry, clerical employees are getting less salary. The clerical employees or accounts, junior level people, right? They're getting very less salary. And only few people are getting less salary, and few people are getting very high salary, and majority of their salary are falling in this range. This is the story we can tell. So it is approximately normally distributed. So can we see any skewness here? Skewness. So this data, does not appear to be, significantly skewed to the left or right, but there is a slight left skew, right? Left skew because one person is falling in the 10,000. Look here, this is 0, right? 0 and little close to 0. No, one. That means 1%. Only 1% is salary is falling between this range. Hence, there is a skewness here. It's an outlier, kind of an outlier. With that, we can make out there is a kind of outlier here. So now you become an expert. If I give you data, you can tell me very clearly what kind of distribution the given data set is. So with this data set, we can tell very clearly it's a normal distribution, the bell curve. It's a bell curve, it's a symmetrical distribution, or we can say that's a Gaussian distribution. Fine. And I don't know what these terms are as a CEO. And if I ask you, can you please explain me in a layman term what this one is? This is a technical chart. Only data scientists can understand. Even a data analyst cannot understand. They are not that good with the histogram. Now you can tell them as a data scientist, right? You can tell them very clearly these stories, whatever I explained to you. The majority of the people's salary are ranging between 40,000 to 60,000. That's what, it's a pretty common sense, right? 130 is almost 400, 500, almost 500 employees. They are getting salary between 30,000 to 50,000. Only one employee is getting, falling in this one, and the 23 employees are, getting very high salary. Right? By looking at this data set itself, now you should be able to tell. Okay, now the question is, how can I? It's a very good question. She asked, how can I create the histogram? Can you please explain? Very good question, Sri. Good that you reminded me. Okay, good. So this is my income, the same data set. You have it here. How do I do that? I just remove it. So you go to Excel, and what you do is, you can put it like this and click on Insert. Okay, I will share the Excel file. Don't worry. Okay. Yes, Jamal and Leela. Yes, I will forward the Excel file. Don't worry. But you need to practice it on your own. Okay. And yes, okay. Any from my side, I'll share it. Look here. I'm going to click on the Insert here. And then here you can see the chart here, right? So column chart. I'm going to click on this chart. First, you need to select. Okay, I will show you one more time. Don't worry. First, you need to select all the values in this data set. Step 1. Step 2, click on the Insert. And then you can see this one, isn't it? The column chart. Look here, what column chart is ready. Fine. And here, you don't need frequency. You can give some title here. Income distribution, something like that. But I removed it so that it will be slightly bigger one, the size. The next, what I'm going to do is I'm going to go to the design. In the design, you will find something quick layout, and here you will find something like this layout 8. That's it. It makes your life very simple, isn't it? This is your histogram. In the case of histogram, you don't see any space between one bar to another bar. Okay, after I plotted this data here, you can see the 0 to 1000, 0, and 10,000 to 20,000, one employee, and 20,000 to 30,000, we can see that 23 employees. Yes, after plotting these values in a chart, we can make out very quickly this data is approximately normally distributed because we have slight skewed data is there. Oh, okay, Jiva, no problem. Okay, fine. So that this is the one, right? So you need to, once you plot this one, so with this, you should be able to see. Now, one thing is you understood how to find out a distribution for, income or something like that. Fine. You need to have the income column, and then you need to use the bin here. You need to specify the frequency also here. Okay. How frequently these, how many number of people or employees are there in each bucket or bracket. This is called bucket. The 10,000, 20,000 bucket, how many employees are there? 20,000, 30,000, how many in this bucket, how many employees are there? Fine. You have this one. With the help of this one, you plotted this chart. Very good. Fine, but this looks good. But when you show it to the CEO, do you think you will be able to understand this one? No, you'll say, hey, come on, what is this? I don't understand. Can you tell me? So my question to you is, as a CEO, right? I'm asking you this question. Can you tell me, are we biased when it comes to giving the salary to our employees? This is what a question. Now, what story you will tell it? You plotted it. You tell him, you can tell, no, sir, we are not biased. We are not biased. Then you need to justify them. Okay, we are not biased because only few of the employees in our company that are getting lesser salary, only few of the employees are getting very high salary. That is quite obvious. Yes. And majority of most of the employees salaries are ranging between 40,000 to 60,000. That's it. Hence, we are not biased. Only few employees are getting lesser, only few employees are getting very high salary. And but there are some cases, right? 50% of the employees are getting very less salary, 50% of the employees are getting very high salary. There could be, that is your kind of, biased salary. Again, you need to take a look at that one very clearly. Okay, so why, are there any problem with the data? Or, are there any problem with our system? Okay, are we biased? Fine. Now you understood what is histogram is all about, or sorry, what is shape of distribution is all about. What is normal distribution? We discussed about that. The properties of normal distribution, the mean, median, mode is equal to 0. Okay, the mean is there in the middle, and mode is also there in the middle. So when you look at the tallest rectangle, the tallest rectangle, with that itself you can find out the median is falling here. The median is falling. Sorry, the mode, right? The mode is falling here. Mean and median and mode, all the three values are same in this data set. Got it? Fine. This is the story. You need to tell it to him. Okay, next one is we are done with normal distribution. So normal distribution. Yeah, and the peak of the histogram. Yes, Sri, in the peak of the histogram, it will show you the most common value in your data set. What is the most common value? 40,000 to 50,000. Okay. And the width of the histogram, you're asking about this one? Okay. The width of the histogram is also, same, right? 0 to 10,000, 10,000, 20,000, 20,000, 30,000, everything is fine. Okay. Yeah. So the width is also fine. So make sure that the widths are somewhat same. For example, you are using 10,000, 20,000. Again, here 20,000 to 40,000. You are not supposed to use that way. But if at all the data have the slight variation in terms of the width in the sense 10,000 to 20,000, the interval, okay, and 20,000. So the difference is 10,000, 10,000, 10,000. It should not be like 10,000, 20,000, again 20,000 to 40,000, 20,000, 20,000, fine. 20,000 to 40,000, again, it should not be, jumping, 20,000, value should not jump here, okay? 10,000, 10,000, interval should be that the difference between the interval should be 10,000, 10,000 across the interval, okay? Okay, next one is the customer spend. There is another example for the distribution, identifying the distribution. Let's I have these are the data set, okay, amount spent by the customer. Remember that in the case of histogram, in the y-axis, what value is there? That is what the question they'll ask. Frequency. Remember that in the histogram, y-axis frequency, we will plot it. In the x-axis, we will plot only the numeric value. You cannot plot any text value in the histogram, okay? Now you tell me, this is the customer spend. Okay. Now you tell me, tell me what is the peak of this histogram? The customer spend. Why don't you tell me some story about this? Type it in the chat window. You can type it in Tamil also, local language. So the peak tells us the most common value in the data set. That means the mode, right? The more frequently occurring value. You remember we discussed about mode. What is the most common customer spending amount in this case? What is the peak here, yeah? This is the peak, right? This is the peak, sorry. This is the peak in this case. Very good, right? Yes. How about others? So in the peak, 100 is there. Guys, please concentrate here. The mode is 100 here, the most frequently, right? The tallest rectangle is the most frequently occurring value. Okay, with that we can understand most of the customers or the most common customer spending amount is $100. We can say this way. So we have more customers. So that means right, there are more customers who spend $100 than any other amount. We can say that also. For example, this is the mean, right? Mean, median, mode. This is a normal distribution. The mean is there in the middle. So this is the most common amount spent by a majority of my customers. What do you mean by majority of the customers? If you see almost 1,500 or so, right? 1,500 customers, right? The amount spent by them is, majority of my customers, the amount spending is $100. But there are customers, they spend more than $100, 120, 140, 160, and there is some outlier here. And again, on their left side, if you see here, there are some kind of customers, they spend less than $100 also. We cannot tell all my customers are spending $100 in my shop. We cannot tell that, right? There are some customers, they spend $100. This kind of customer, they spend $80. Some customers, they spend $10 also, $5 also, $1 also. Different customers, they spend different money in your shop. But what is the common amount spent by majority of your customer? If they ask you, you just see the peak and close your eyes and tell, hey, $100 in the case of symmetrical distribution. Okay. In this case, the customers spend more than $120 also, right? There are some customers, they're spending more than $120 also. And if you see, right, majority of the customer, $100 to $120. This one, right? 120, so almost 100 to, we can say 110, 100 to $110 spent by majority of the, we can say that also. Okay, but this is the most common value. Most common value is your peak. And and then you can say the most of the employees, they spend between $100 to $120 also, we can say, right? $120 also reasonably okay only, $120. Okay, and if you look at the tails of the histogram, it shows the outlier in the data set. There are a few customers who spend significantly very less money here. Maybe this guy is spending, he spent $1, but these guys are, only one customer, he spent $160, and so few customers, they spend more, and only few customers, they spend less. We can see here itself the outlier. It's kind of an outlier. So overall, the histogram shows the distribution of the customer spending is approximately symmetric, with a peak value of $100. But there is with that we can understand there is a fair amount of variation in customer spending. There are few outliers also there. This is the story you need to tell. Okay, the next one is the most customers spend around $100. The distribution of customers spend approximately symmetric. Okay, and next one is, so far we discussed the normal distribution. Okay, to summarize the normal distribution, in the case of normal distribution, the values of mean, median, and mode will be there in the middle. The mean is equivalent to median is equal to mode. All the three values are same. That means it appears in the middle, all the three values. Okay, the symmetric distribution is, or the normal distribution is nothing but it is a type of a distribution where the left side of your distribution mirrors the right side.